I'm over here ripping trees. By the river, that river.
All right, so
It was like a running away.
Mr. Colon,
What?
Miss Hart, Mr. Narens, and Miss Snodgrass, you owe me a quiz. Tomorrow, I'll give you 1 day to look it over. Yes, you are. All right, I gotta get it done by tomorrow. You guys forgot that we're here?
Yeah, sure. I never, what was it on? I didn't know what
Yeah.
I got like a 35.
All right, so if you guys were looking like Zach was, we have a quiz on Friday. So what we learned today and tomorrow is what's going to be on it. Basically what we learned today. Oops, I forgot to save that. Okay, so as you can see, we're solving radical equations and inequality. Harris, what's an inequality?
That's when I was like, less than or equal to 9.
Yes, it is. Very good, sir. So we're going to have some radical equations with radicals in them. That's square root symbols, cube roots, that kind of stuff, right, Andrew?
Yeah.
So we did some work on that before we left for our break. And it's simple. So we're going to do radical equations and radical inequalities. A radical equation contains a variable within a radical. So in our radicand, underneath that radical sign, we'll have a variable in it. Recall that you can solve quadratic equations by taking the square root of both sides, remember? Similarly, radical equations can be solved by raising both sides to a power. So if I have square root on both sides, or one side, to get rid of that square root symbol, I'm going to square both sides. You know, the same rules. What you do to one side, you got to do the other, right? If it's cube root, I wouldn't square both sides. What would I do? Cube both sides, right? If it was fourth root, I'd raise it to the fourth power both sides, okay? So that's all we're going to do to get rid of that radical sign. Okay, so first thing to do is isolate the radical. So on this problem, we had to add 2 to both sides to isolate the radical. So we got the cube root of x equals 2. So to get rid of the cube root, what do I got to do to both sides? Cube both sides, all right? And what is the cube root of something cubed? Itself, right? So whatever's under that radical sign is what is going to be left. And in this case, it's just the x, and then 2 cubed is 8. Okay? So again, for square root, we don't usually put the index of a 2 there, right? We just understand it's square root, right? So if we have that symbol, we're going to square both sides to get rid of that radical sign. Okay? Make sense? Simple, right? So what do I got to do first in this problem? Subtract the 5, right? I got to get the radical part alone. So what's 16 minus 5? 11, yeah. So now it looks like this. So since that's square root, I'm going to square both sides. What's the square root of x plus 1 squared? X plus 1, right? And what's 11 squared? 121. You guys are so smart. So what's my answer? 120. Subtract the 1. Simple, right? That makes sense? Not so bad, right, so far?
It's gonna like.
Right, so. Okay? Any questions? Not much tougher than that. Okay? Yeah, you guys can do this. All right, so here's one. What do you think I have to do first? Divide by 5, very good. Because it's 5 times this, right? There was no symbol between them, so that means multiplication. So to move it, we're gonna do that division, right? Which you to one side, you gotta do the other, right? So now I got the cube root of 4x plus 3 equals what? 3. Now, this is a little different because it's cube root. So what do I do to both sides? Cube both sides. So I gotta do this, right? So what's my left side gonna be? 4x plus 3, very good. And then what's the right side? 27. 3 times 3 times 3. And then we just finish up, right? Subtract 3. And then divide by 4. So our answer is 6. Okay? Does that make sense? Not bad, is it? Okay. Any questions? Again, now's the time to ask, right, Nicole and Jordan? Making sense? All right. Now, sometimes you'll have a radical on both sides, like this. Okay? So, there's nothing we can do to simplify anything right now. So I just need to do what to both sides? Square both sides. Okay? Which I think they have it written for us here. Yeah. So, what's the left side? So, 2. What's the right side then? 9 and times what? 3x minus 2. So remember, you're going to square the 3 outside also, which is a 9. So now what do I have to do with that 9? Distribute it, right? Making sense? So we got what, 27 minus 18? Oops. So far, so good? And then what am I going to do? You could subtract the 7x, or you could subtract the 27x, right? I don't know what they did. Let's see. I think they're going to subtract the 27x. No, they didn't. So they did 2 steps at once. So let me draw those in there for you, just so we all follow it. So we're going to add the 18. That's where the 20 came from, right? And subtract the 7x. That's where that 20 came from, the 20x, right? Makes sense? Now divide both sides by 20 and we get what? 1, right? So you'll get this situation sometimes where you have a radical on both sides. It's not too bad when it's 3 times that. When it's 3 plus that, it's a little bit different. Okay, let's see if we have one of those. I think we might. No, not that one. So here we're going to do what to both sides? Square. So we just get 8x plus 6 on the left, and what on the right? 9x, right? So we just subtract the 8x, and this is real easy. We get 6 equals x, right? So far, so good? That wasn't too bad. But I think they're going to throw a plus or minus sign between the 3 and the radical on us. Oops, did I go 2 times? All right, what would I do to both sides here? Cube. All right, so what's the left? X plus 6. What's the right? 8. Good. Because 2 times 2 times 2 is 8, right? My sleeve keeps sitting. So I got to distribute the 8. And then I guess I'll add the 8 and subtract the x to keep my x positive. So we have what, 14 and 7? So what do we get? 2. Making sense so far? So maybe they don't give us a 2 plus or 2 minus in there. So I'm not going to worry about it unless they give us one of those. All right. Raising each side of an equation to an even power may introduce extraneous solutions. What are those again? Doesn't work, right? When you plug it in, doesn't work, right? You can use the intersect feature on a graphing calculator to find the point where the 2 curves intersect if you want. Okay? So, using the calculator, they go to the what? What's that say? Y equals, right? You guys know where that is on your calculator, right? So, if you go to your y equals, you just put square root, second squared, and then negative 3x plus, oops, not plus 33. So I'll have to close that up, right? Some of you don't have to do that, close it, because you don't see that parenthesis. And then you do the 5 minus x for the second one. Hit enter. And then just hit graph, and it should show both graphs. There's the. So to find this, to get this intersection, go to second, calculate. Second trace, sorry, which is calculate. Number 5's intersect. So it says first curve, just hit enter. Second curve, hit enter. And then guess, hit enter. There's a negative 1, 6. And we're looking for what x equals, so what's the answer? Negative 1. That's doing it graphically. Okay? Using your graphing calculator. Doing it algebra, what do you got to do to both sides? Square them, right? Now, how do I square 5 minus x? It's FOIL, right? We call it foiling. Remember, it's going to be 5 minus x times 5 minus x. So it's not just the 5 squared, 25, and the negative x squared. You got that outside and inside. So you get that negative 10x in the middle. All right. There's your 25. Outside is negative 5x. Inside is negative 5x. That's where that negative 10x comes from. And then your last, negative x times negative x is that positive x squared. All right, so don't forget that. A lot of kids will just write the 25 and the plus x squared. Remember, you're going to have to write it twice and FOIL it. Okay? So it turned into what type of problem? A quadratic, right. We're going to do what then? Starts with an F. Factor. We had to FOIL, yeah, to get there, but then we're going to end up setting it equal to 0, remember, in factoring, which we had to do on the last quiz a little bit also, didn't we? So, add the 3x. That's where the negative 7x comes from. And subtract the 33. That's where the negative 8 comes from. And then when you factor it, negative 8 times a positive 1 is negative 8. and negative 8 plus positive 1 is negative 7. So what are my two answers? What makes this 0? 8 and negative 1, right? Right, Colli? So they, you set them both equal to 0 and you get 8 or negative 1. Then we got to do what? We're supposed to be checking these. Okay, so go to the original problem. What's negative 3 times 8? Negative 24 plus 33? 9. What's the square root of 9? 3, right? So when I put 8 in there, I get 3 on the left. What's 5 minus 8? Negative 3. Are those two equal? No. So does 8 work? No. So that's an extraneous solution. Okay? So then when I put negative 1, what's negative 3 times negative 1? Positive 3 plus 33. 36. What's the square root of 36? 6. What's 5 minus a negative 1? That's 6. Those are okay, right? Those are equal. So I think they do it on the next slide, the check. Yeah, here's the check for both. All right. So these are not equal, and these are. So the only one that works is negative 1. So you should check your answers like we've done in the past. Make sure they're working. All right. So what happened here? Remember, what was a little different is we had a binomial that we were squaring, so we had to FOIL it. Then it turned into a quadratic for us, which we've done all kinds of those, right? Questions? All right. Okay. All right, so this is going to happen again. Again, how will we do it graphically? Put it in the y equals, right? So go back to your y equals. You got the square root already there. So just put 2x plus 14. All right. And then the x plus 3. And then graph and see where they meet. Okay, so how do I get to that intersect again? Second trace. Number 5 is for intersect. And just hit enter 3 times. First curve, it's on the first one that it showed. Second curve, it's on the second one if you did. And then the guess is where they meet. 1, 4 is that intersect. So what's the x value? 1. So that's going to be my answer. Okay? It's the x value we're looking for. Does that make sense? So graphically, in our graphing calculator, we get 1. All right? Using algebra, what's the left side? Thanks, you guys. All right, remember, x plus 3 squared is this. All right, so what's first? X squared. What's outside? 3x. What's inside? 3x. What's last? 9. Okay? So we got that x squared, so we're going to have to set it equal to 0, right? So I'm going to subtract 2x and the 14. And see what we get. So we get a 0 here, x squared. 3 plus 3 is 6, minus 2 is 4, and 9 minus 14 is a negative 5. Are there factors of negative 5 that add up to 4? 5 and negative 1, very good. So we get a 1 and a negative 5, right? And we got to check. Well, we know which one's going to work. Which one? the 1 from the graph, when we check -5, okay, what's 2 times -5? -10 plus 14, 4. What's the square root of 4? 2. And then what's -5 plus 3? They equal? No. So then we have to get rid of the -5. Making sense? All right, so those are the radical equations. What were the other things we were doing? Radical inequality. So now we're going to do the same thing, but have, oh, let's look at this first before we do the inequality. 1/2 power is the same as square root. 1/3 power is the same as cube root. So if we get these fractional exponents, again, that just means this for 1/2. We're just squaring both sides. What happens to the 1/2 and the 2? They just cancel. That's all that's happening there, right? 1/2 times 2 is 1. So x plus 12 to the first is x plus 12. So it's the same thing. We're just writing it in a fractional exponent, or we call them rational exponents on the last quiz. Okay, so it's the same thing as square root or cube root, right? What are we going to do to both sides here? Cube, all right? So when we cube, we get this. Subtract 7, divide by 5, and we'll get 4. So it's the same type of problem. So I don't want you to get messed up when you see those fractions, okay? Any questions on that? Okay, good. So inequalities, that one we'd go, what would we do to both sides? Square. This one, cube. All right. That one, square. So you'll see a couple of those too. All right. So we got inequalities. All right, same type of deal. Says a radical expression with an even index and a negative radicand, remember, has no answers, no real answers. That's what we're always looking for, right? Real answers, not the non-reals, not the imaginary unit that i's, okay? All right, so we can do the same thing here as we did. All right, you can do the plus 3 and that, and then, graph them. Okay, so the answer is 21, all right? Or you can look at the table and see that. Now, how did they get this part? Okay, I'll show you that in a minute. Okay, that's using the graphing calculator again. Let's do the algebra part. Okay, what are we going to do first? Subtract the 3 first, right? Now, we want the radical part alone before we square or cube or whatever we have to do. All right? So we do that. Now we square both sides, right? What's on the left?
6.
Right?
36.
36. Okay? Now, they did also what? They added the 6, right? So I'll put that in there. Sometimes they skip the steps on us. So we added 6 to both sides. Why does that keep happening? My sleeve keeps going out. All right, so what's the answer here? 21, right? That's part 1. There's 2 parts to this when it's the inequalities. What type of number is this not allowed to be? Negative, right? So what we do, I don't know if they do it. Yeah, it's on the next one. What's this mean? Greater than or equal to 0, right? Which means what type of numbers are greater than or equal to 0? Positives, right? So this number could be 0 or positive. That's okay, because what's the square root of 0? 0, right? We just can't have the square root of a negative. So that's why it's always whatever's underneath the radical sign, whatever's underneath is greater than or equal to 0 is the problem you have to do for the other side of your inequality. All right? So you add 6. And then divide by 2. That's where the greater than or equal to 3 comes from. All right? So x is greater than or equal to 3 and less than or equal to 21, which most of the time we just write it like this. X is between 3 and 21. You can do either way. Write it with and or do the 2 less than or equal to. Okay? So again, here was our original problem. Okay? What's going to happen on number 2 here? Cube both sides, so what's 3 cubed? 27, right? So don't forget about that, then you'll distribute the 27. All right, so that's it for today. There's your assignment. Good job for the start. You got time. You got about 15 minutes. You can get some of it done. If you are a person that has to make, excuse me, make up that quiz, you got some questions now, might be a good time to ask me, go over anything you might have a question on. That's fine. We got to get it done by tomorrow, remember.